Hello, and welcome to the Federal Railroad Administration's Rail Program Delivery video series. I'm Anthony Thomas, and I'm pleased to introduce Dick Cogswell, engineer with the FRA.
Hello, everyone.
In this video, we'll cover the preliminary engineering, or PE process, as well as the grantees and FRA's responsibilities in the process. During PE, the grantee will take the 15% level of design that was developed in service planning and concept design, incorporate information developed in the environmental review process, and perform additional engineering work to get to the 30% level of design, which demonstrates that the project is feasible and that the program requirements are fulfilled. Based on the 30% design, the grantee will develop a schedule and cost estimate for the project. FRA then reviews and approves the PE package and provides technical assistance as needed.
As part of PE, grantees will finalize the design criteria for their project's infrastructure and operations and prepare design drawings based on surveys, maps, and information about existing conditions.
PE is a critical component of the project development process. Preliminary engineering follows service planning and conceptual engineering. Environmental review is conducted concurrently with PE. After the PE package is approved, the scope, schedule, and budget that were developed in PE are further developed in final design. The work done during PE is critical to ensuring that construction goes smoothly and that the completed project operates successfully.
The relationship between preliminary engineering and environmental review is especially important since they are conducted concurrently. Environmental review relies on the PE design drawings and supporting information, and PE is based on the preferred alternative that is identified in the NEPA process.
During the NEPA process, grantees assess various reasonable alternatives for their environmental impacts, among other factors. The analysis results in a preferred alternative, which is carried forward into preliminary engineering. Though the PE package may acknowledge other alternatives that were considered, the final PE package focuses exclusively on the preferred alternative.
You may not submit your final PE package for approval until after the NEPA decision is issued and its results have been incorporated into preliminary engineering.
You'll use key information gathered and decisions made in prior project development phases in your preliminary engineering work. This will include the Project Management Plan, or PMP, which describes the grantee's authority, capacity, policies, practices, and procedures related to all phases of the project, and sets forth a specific action plan for implementing the project and for managing its scope, cost, schedule, quality, and associated risks. And the Financial Plan, which demonstrates how the project will be funded for construction, showing sources and uses of funds, costs of borrowing, timing of funding availability, and project cash flow.
For the preferred alternative, the PE package that the grantee will submit for FRA approval includes the following: a statement of project goals and objectives, including any outcome performance measures associated with the grant, such as adding new service, reducing trip time, or increasing system reliability. A project description, the scope as shown in drawings, specifications, design criteria reports, and other documents. A project schedule, and a capital cost estimate.
Let's go over the three key aspects that make up the PE process. After your project goals and objectives and descriptions are prepared, you'll develop your project scope, which includes most of the engineering work you'll perform during PE. Then, based on the scope, you'll develop a project schedule and then a cost estimate for your project. We will walk you through each of these elements, noting some helpful tips and reminders along the way. When developing the project scope, consideration needs to be given to information on existing conditions, including surveys and mapping, the basis of design for various project elements, and design drawings and specifications. We will briefly introduce each of these now.
Existing conditions, surveys, and mapping. You'll need to document the existing conditions in your project area with surveys and maps. These will demonstrate an understanding of the current infrastructure and the opportunities and challenges they present for your project. Be sure to include scaled maps or aerial photographs of existing conditions, including the existing right-of-way limits with railroad and property ownership, and drawings of the existing track configuration and signal system, block configuration, signal equipment locations, and station.
Basis of design. The basis of design, which you will have prepared during conceptual engineering prior to PE, presents the technical criteria to be followed for the design of your project. During PE, you will update the basis of design to document the details for the scope of your project and the process for rail project build-out. The basis of design will also describe possible design variances in cases where physical conditions or engineering solutions cannot achieve the design criteria. For example, your basis of design may include a design variance for the placement of a station platform relative to the location of active freight tracks if the station area is too constricted to meet the proposed standard.
Design drawings and specifications. For a railroad project, the drawings will typically include civil works, including grading and drainage, track configuration plans, station plans, and signal schematics, including provisions for positive train control. Track configuration plans typically include the following: proposed track changes, including the removal of existing track and installation of new track, track centers, speeds, turnout sizes, curves, and spiral data, vertical profiles and grades of existing and proposed construction, typical cross-sections showing proposed changes in track configuration and other locations that will require retaining walls or right-of-way acquisition, and parking, access to local highways and public transit services. For complicated track configurations, you'll need to prepare drawings of the existing and proposed signal designs. The drawings should include route and aspect charts, preliminary block design, and signal equipment locations.
When you're conducting the engineering work to develop your project scope, you should keep several things in mind. We'll look specifically at safety and security, environmental review, the Americans with Disabilities Act, track configuration, and construction and utilities. Be sure to address these issues early so that problems do not arise later in the project development process.
Safety and security. The design that you develop as part of your project scope should consider safety and security as a top priority. It should address safety and security for construction workers, train and station personnel, passengers, the public, and the equipment during construction, testing, and once the project is up and running. Be sure to coordinate with your FRA regional team's safety expert.
Environmental review. As mentioned previously, the PE design work is used to support the environmental review process. The final environmental decision, which includes the selection of a preferred alternative, must be complete prior to finishing PE. The scope, schedule, and cost estimate proposed in the PE package must align with the preferred alternative identified in the environmental review process. Work closely with your FRA regional team's environmental specialists to make sure that you are on the right track. Also, see our environmental review video for more information.
Americans with Disabilities Act. Think carefully about ADA compliance throughout PE. Any publicly or privately funded rail project of public accommodation must be accessible to persons with disabilities. That means the rail stations and platforms must be accessible to people with visual, hearing, mobility, or other physical impairments. Considering ADA requirements early and often in the PE process will make it easier to address and mitigate accessibility issues as they arise. See our ADA video for more information on making your project accessible to persons with disabilities.
Track configuration. You'll need to consider how your project will affect existing track configuration. Will your project require the relocation of any through or passing tracks? Will any new or modified stations change how other rail traffic moves nearby? Track configuration cannot be changed after your 30% design is completed in PE and must be agreed to by all relevant stakeholders, including the FRA and the railroad owner and operators on the lines affected by your project. Your FRA regional team's engineer can help you address any track configuration challenges that arise.
Construction and utilities. During PE, you'll also need to consider how your project will be constructed. Will temporary construction facilities be required? If so, you will need to include them in your NEPA analysis. Will construction take place in phases or all at once? How will construction materials be delivered to the job site? Also, you should be aware of the location of utilities and understand how your project will impact or be impacted by them. If you wait until final design or when you are ready to begin construction to consider these issues, any changes you make to accommodate unanticipated construction and utility issues could increase the cost and delay the schedule of your project.
Once you've defined your project scope, you'll prepare a project schedule based on the design drawings and specifications that you developed earlier.
The project schedule should reflect a realistic time frame to complete the phases of final design, construction, testing, and operation of the service. Pay particular attention to the long lead times for procuring signaling and other complex equipment, which may take 12 to 18 months. The project schedule must address project risk, which may result in delays, through the inclusion of schedule contingency or float.
By the time you develop your schedule, you will have addressed all of the issues that we discussed during the scope section. For the schedule, and later, for the cost estimate as well, you'll need to consider Buy America requirements.
Buy America and its related acts require that all of the iron, steel, and manufactured components used in the construction of rail projects be produced in the United States. These provisions ensure that the transportation infrastructure projects are built with American-made products. When developing cost estimates and schedules, grantees should be aware of the capacity of domestic manufacturers and fabricators to produce the materials and products needed for the project, and to build in appropriate cost and time. Visit FRA's Buy America website for more information on the requirements.
Finally, you'll prepare a project cost estimate that reflects the proposed project schedule and the project scope as portrayed in the 30% design drawings and specifications.
The project cost estimate should be presented in the standard cost category format and should include all costs to implement the project for all relevant phases, such as PE, final design, construction, testing, and startup. Refer to FRA's capital cost guidance for additional information, which is available on the FRA website shown here.
Here are a few helpful tips for you to consider in preliminary engineering. Be mindful that the amount of time and effort required for PE and the NEPA decision hinges on the scope and complexity of the engineering, environmental, social, and regulatory issues to be addressed. Keeping environmental, ADA, Buy America, and other federal requirements in mind early in the PE process will help you avoid problems later.
We recommend that you coordinate early and often with your project stakeholders to incorporate their needs and concerns during PE. Stakeholders often include railroad owners and operators, local officials, nearby residents, as well as the potential users of the new or improved service. Coordinating with a railroad owner is especially important, as the construction may have an impact on the railroad itself or on operators who also use the line.
Additionally, be sure to consider existing railroad operations and how the rail project might impact them or be impacted by them. You'll need to provide specific details about the project regarding train length and speed and whether high-level platforms will be present.
Finally, as part of PE design, consider the trade-offs between near-term capital and long-term operations and maintenance costs for a minimum horizon of 20 years. Be sure to look for opportunities to make upfront capital investments that reduce long-term maintenance costs.
So how do grantees know when they are ready to submit their PE packages to FRA for final approval?
PE activities are complete once the following items have been demonstrated and approved by stakeholders and FRA. A level design for the preferred alternative that demonstrates project feasibility and achievement of program requirements. The NEPA review is complete and a final decision document has been submitted. A scaled set of drawings have been signed off by the grantee, host railroad, Amtrak, local governments, and FRA, indicating their concurrence with the project. All federal and FRA program requirements for PE have been met. These include, but are not limited to, grant requirements, the Americans with Disabilities Act, and Buy America. Coordinate with your FRA regional team and/or your grant manager to ensure that you are complying with these requirements.
Let's take a brief look at the final PE package you will submit to FRA for review and approval.
The items that must be included in a final PE submission are a cover sheet to be signed by the FRA chief engineer and senior executives with signatory authority from all stakeholders, a description of the goals, objectives, and outcome performance measures of the project, design drawings and specifications for track signaling, including positive train control implementation, stations, maintenance facilities, specifications, studies, reports, plats, maps, and other engineering and surveying work products, route and aspect charts if necessary, staging plans if necessary, project schedule, and project cost estimate.
FRA's review of the PE package takes approximately 4 weeks. The FRA regional manager responsible for your project will review your PE submission with the regional engineer and other members of the FRA review team. The regional manager and engineer review the design drawings, cost estimate, project schedule, and other elements to ensure that they conform to the grant agreement, scope of work, and expected project outcomes. Once the review is completed, the regional manager will notify the grantee of PE approval, which allows the grantee to initiate final design, pending available funding.
Preliminary engineering establishes the project foundation, the essential activities, milestones, and documents necessary for approval and advancement of a project. A comprehensive preliminary engineering process will help to minimize time and cost delays in the final design and construction phases of the project.
For more information about preliminary engineering, please visit the links listed below. Thank you.